Welcome to this lesson on availability zones and high availability design. Availability zones are a fundamental building block of cloud architecture that help us create systems that can withstand failures and remain operational. Understanding how to use availability zones properly is essential for designing fault-tolerant applications in the cloud. An availability zone, often abbreviated as a Z, is one or more isolated data centers within a cloud region. Each availability zone has its own independent power supply, cooling systems, and networking infrastructure. This isolation is crucial because it means that if something goes wrong in one availability zone, such as a power outage or hardware failure, it won't affect the other availability zones in the same region. Let's visualize how availability zones work within a cloud region. A region, such as US East 1, typically contains multiple availability zones. In this example, we have three availability zones, a Z-A, a Z-B, and a Z-C. These zones are physically separated from each other, often by several miles, but they're connected through high-speed, low-latency networks. This setup allows them to communicate quickly while remaining independent from a failure perspective. Availability zones have four key characteristics that make them essential for high availability. First, they have isolated infrastructure, meaning each zone has its own power, cooling, and networking that doesn't depend on other zones. Second, they maintain low-latency connections through high-speed private links between zones. Third, there's physical separation, with each zone located in geographically distinct locations within the region. Finally, they provide fault isolation, which means failures are contained within a single availability zone and don't cascade to others. High availability, or HA, is a design principle that ensures your systems remain operational and accessible with minimal downtime. The key to achieving high availability is redundancy across multiple availability zones. By distributing your application components across different zones, you create a safety net. If one zone experiences issues, your application continues running from the other zones without interruption. Here's a practical example of multi-AZ deployment in action. Imagine you've deployed your application across three availability zones, a Z-A, a Z-B, and a Z-C. Now, suppose a Z-A experiences a complete failure, perhaps due to a data center issue. Because you designed your application to run across multiple zones, the application automatically continues serving users from a Z-B and a Z-C. Your users experience no downtime, and the application remains fully available. This is the power of multi-AZ architecture. Let's discuss three essential best practices for designing with availability zones. First, always deploy your resources across multiple AZs, ideally at least 2 to 3 zones. This ensures redundancy. Second, use load balancers to automatically route traffic to healthy instances across your zones. Load balancers detect when instances fail and redirect traffic accordingly. Third, replicate your data across zones to maintain synchronized copies. This ensures that even if one zone goes down, your data remains accessible and up to date from other zones. To wrap up, remember this key takeaway. Availability zones are the foundation of fault-tolerant cloud architecture. By distributing your workloads across multiple AZs, your applications achieve resilience against infrastructure failures. The philosophy here is simple: build for failure, design for success. Always assume that failures will happen and design your systems to handle them gracefully. When you embrace this mindset and use availability zones effectively, you create applications that are robust, reliable, and ready for production.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.